We are still in investigation 3.1. And where we are right now is we are in 3.1, Part C, number 2, where they're asking us to write an equation for your rule using letters to represent the variables. All right, so this is actually quite a bit of information that we need to cover for this. So what I'm going to do is whenever we write a rule, we're always looking at a table. All right, so you need a table of data first before you can actually write a rule. Even if you had a graph, you would still need to basically figure out the data in order to begin to write the rule. All right, but having a graph, I mean, you can do it, but it's just a little bit more complicated. All right, so we're going to start with the table because that's the easiest way to do it. Now, in our last lesson, we basically found, and I'm going to take the 51, that the pattern was increasing by 50. All right, and remember before we said the trick was this should be increasing by 1. All right, as long as that's increasing by 1, then whatever the pattern is, and this is my x, then whatever the pattern is for my y variable, that's basically what you're increasing by. All right, so the y variable is the one that actually determines what the pattern is. So the pattern is increasing by 50 every hour. So 50 miles every hour is what we increase by. All right, now to write a rule, here's how we do this. To write a rule, you are always writing the rule for the independent variable. Because that's what we're always trying to find. Because remember, the dependent variable, it can exist by itself, so therefore there's nothing that you have to do. So my independent variable, how do I get the independent variable? Well, what we have is our starting point is the value of y when x equals 0 is what goes first, plus my dependent variable and I'm going to write the time symbol, and I'm going to explain to you the problem with that, but I'm just using it for now, times the pattern found in y variable, or basically just the pattern. All right, so that all seems very, very complicated, but it's really not. So what we have is this. Our independent variable is time. So time equals the value of y when x equals 0. So when x is 0, y is 0. So that's 0. Plus my dependent variable, which we said is distance, oh, I just did this backwards, didn't I? How come no one stopped me and corrected me? Oh, I'm so disappointed in you guys. So disappointed. All right. Independent variable, distance, equals, yes, I could have edited that out, but that would take the fun out of this. So distance equals 0 plus dependent variable, which is time. So remember, that's my x. This is my y. Yes, I actually did make a mistake. Don't tell nobody. Times the pattern found, which was 50. Okay, it's increasing by 50 every single time. All right, now, So that's basically your standard format for the formula. We're going to clean it up because they asked us to do it using letters for the variables, and we're going to get rid of this whole 0 plus, because 0 plus anything is just a something. So next step down. What we are going to do is we're going to make a little key, and we're going to say distance equals d, and time equals t. So now we're just going to substitute. All right, so distance d equals 0 plus time is t times 50. All right, so we're getting closer and closer. All right, now, as I was saying before, 0 plus anything, the 0 might as well not even be there. So what that leaves me with is d equals t times 50. All right, now we're almost there. Here's where the problem comes in. All right, what I was trying to tell you guys is the time symbol. We have a problem with the time symbol. We can't use that anymore since we're now dealing with algebra. And the main reason why is because I have no way of determining if that X symbol is the time symbol or whether it stands for a variable. Because remember, we're trying to go from words to letters. So we went from distance to just D, time to just T. X could be anything, okay? X could be the time symbol. X could stand for a variable name. I mean, because remember, we didn't have to call distance D. We could have said distance was P and time was X, okay? However it is that you want to word it, okay? It's up to you. It's just that it just seemed to make sense to call distance D and time T. Seemed easy enough. So we have to get rid of this time symbol. So what we do is D equals, yes, I'm bending over, that's why I'm groaning, T, little time symbol with the dot, 50. All right, so now that's one way to do it. The other way to do it, Jesus Christ, I'm running out of colors, excuse me for that, is to basically say D equals 50 T. Okay, I don't need to put the dot because if I have a number and a letter, it's automatically assumed that the operation in between is 50. Okay, so what I'm going to do is in your notes section, anytime, anytime a letter, meaning variable, is next to a number, without an operation in between, it is assumed the operation is multiplication. So an example would be 60 T, which actually means 60 times T. Okay? Now, one little note that I want to put on here, and that is, you notice that I switched the order. I put the number first and then the letter. All right? that is actually the standard way that they like to do it. So what actually happens is when you get to this point right here, you'll probably want to switch these around and say, switch these two things around. So say the pattern found in variable times the dependent variable. And then that would make the next line 50 times time. Yeah, that actually makes more sense than having it written the way that I wrote it. So I'm not going to redo this video just for that. So as if it was in class, I'm asking you guys to basically fix this. Okay? So take this part and switch it with that. The wording's the same, just switch the order. Okay? And that will just make it so much simpler, and then you won't have to remember to put the number in front of the letter. All right? And again, we'll talk about this more. You guys can tell me how confusing and how annoying that was. I should have just re-recorded, but I'm not going to. Okay? We do this once, one take only. All right. So now you guys know how to write an equation. You always use this format. Okay? Now, writing an equation / rule only works if there is a pattern. Okay? So you can't really write an equation for something if there's no pattern. It's just not going to work. That just makes sense. Okay? And the value of y when x equals 0, sometimes this will be a value. It'll actually be a number. All right, but again, we're going to work through this whole process as time goes, and we're going to clean this up a little bit more, because I actually just thought of another switch I'd like to do, but I'm not going to tell you right now. So let's just get this down, and then we'll go from here.